All right, guys. So this problem, a few different things that you have learned about. So it says, given the quadratic equation, f of x equals x minus 5 times x plus 1, and the vertex given at 3, -9. Okay, they want you to identify the x-intercepts, and they want you to graph the quadratic. So don't overthink this problem. The first thing you don't want to do is you don't need to FOIL here. You don't need to do anything like that. You don't need to use the opposite b over 2a because we're giving you the vertex. So the vertex is given to you. All right, so we need to understand this from yesterday, that this is called factored form. We talked about that in a previous video, okay, where these are the factors of a quadratic equation, okay? So when you have factored form, if you apply that zero product property, you can easily get the x-intercepts, which means, okay, you're going to replace f of x with 0, and then you're going to solve it by setting each figure separately to equal 0. Remember, zero product property basically states, okay, if the product of these two equals 0, then one or both of these has to equal 0. Common sense. So we have x minus 5 equals 0 and x plus 1 equals 0. And then you just solve it like two simple equations. So that's x equals 5, and then subtract 1, x equals -1. All right, so now you understand that when you are solving a quadratic, you are solving for its x-intercepts. So this has a point, because it is an x-intercept, which means it's sitting on the x-axis, it's the point 5, 0. Here, this is the point -1, 0, because we're dealing with x-intercepts. So now let's plot these on our grid over here. So we have 1, 2, 3, 4, 5. There's your first x-intercept, and then here's your second x-intercept. All right, now we're going to graph the vertex. If you recall from the last lesson that you guys did, the vertex is that middle part of the problem. So here, it's going to be 1, 2, 3, and then down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, right about here. Okay? All right? And then as carefully as you can, you sketch your curve. Not my neatest work, but I'm sure you guys can do better. All right? So I'm going to have you guys try a few of these on your own. Good luck.